Article 680.21c states that pumps shall not be installed in an area that may be subject to flooding. Article 680.22 addresses scenarios where the wet niche luminaire and the pump motor are supplied by the same branch circuit, stipulating that the branch circuit must have a ground fault circuit interrupter or GFCI. Article 680.24 mandates that all wiring must be protected from physical damage and that electrical equipment shall be installed to protect it from the damaging effects of submersion. Considering these code references, running 12/2 UF cable to feed the pump motor is not a good idea. What is being described is generally how the electrical system for an in-ground pool is installed. However, an above-ground pool does not have a wet niche, and the electrical components are not installed underground. The inspector is correct in requiring the use of PVC conduit with an insulated ground wire and expansion joints in the pipe. Let's delve deeper into the reasons behind these code requirements and the proper installation methods. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent electrical hazards. In the context of swimming pools, both in ground and above ground, the NEC addresses the specific risks associated with water and electricity. These risks include electric shock, electrocution, and equipment damage due to submersion or physical damage. Firstly, let's discuss the limitations of UF cable in this application. UF cable, or underground feeder cable, is designed for direct burial in the earth. While it is water resistant, it is not intended for continuous submersion or exposure to harsh environmental conditions above ground. In the case of an above-ground pool, the wiring may be exposed to sunlight, rain, and physical contact, which can degrade the cable's insulation over time. This degradation can lead to electrical shorts, ground faults, and potential safety hazards. Secondly, the use of PVC conduit offers superior protection for the wiring. PVC conduit is a rigid, non-metallic tubing that encases the electrical conductors, providing a physical barrier against damage from impact, abrasion, and environmental factors. It is also resistant to corrosion and chemicals, making it suitable for use in wet or damp locations around pools. When properly installed, PVC conduit protects the wiring from physical damage and helps to prevent water from entering the electrical system. Thirdly, the insulated ground wire is an essential safety component of the electrical system. The ground wire provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker or GFCI and energizing the circuit. This helps to prevent electrical shock in the event of a ground fault, such as a wire coming into contact with a grounded metal part. In the context of a pool pump motor, the ground wire is connected to the motor housing and any other metal parts that could become energized. Fourthly, expansion joints are necessary to accommodate the thermal expansion and contraction of PVC conduit. PVC material expands and contracts with changes in temperature. Without expansion joints, the conduit can buckle or crack, potentially damaging the wiring inside and compromising the integrity of the electrical system. Expansion joints are flexible couplings that allow the conduit to move without putting stress on the joints or connections. Now let's explore the specific requirements outlined in Article 680 of the NEC, which covers swimming pools, fountains, and similar installations. Article 680.21c, as mentioned earlier, prohibits the installation of pumps in areas subject to flooding. This is because submersion of electrical equipment can create a significant electrical hazard. If the pump motor or its wiring becomes submerged, there is a risk of electrical shock and equipment damage. Article 680.22 addresses the use of ground fault circuit interrupters or GFCIs. A GFCI is a device that monitors the current flowing in a circuit and detects any imbalance between the hot and neutral conductors. If an imbalance is detected, indicating a ground fall, the GFCI will quickly trip the circuit, cutting off power and preventing electrical shock. GFCIs are required for all electrical outlets and equipment located near swimming pools, including pump motors and lighting fixtures. Article 680.24 emphasizes the importance of protecting wiring from physical damage and submersion. This section requires that all wiring be installed in a manner that prevents damage from impact, abrasion, and exposure to water. The use of PVC conduit, as previously discussed, is a common method of complying with this requirement. In addition to these specific requirements, there are other relevant sections of the NEC that apply to pool pump motor installations. Firstly, Article 430 covers motors and motor circuits. This article provides guidelines for selecting the appropriate size conductors, overcurrent protection, and disconnecting means for motor circuits. Secondly, Article 250 covers grounding and bonding. This article provides requirements for grounding electrical systems and equipment to ensure safety and prevent electrical shock. Thirdly, Article 300 covers wiring methods. This article provides general requirements for the installation of wiring, including the use of approved raceways, cables, and connectors. When installing the electrical system for an above-ground pool pump motor, it is important to follow all applicable requirements of the NEC and local codes. This includes obtaining the necessary permits and inspections to ensure that the installation is safe and compliant. Now, let's discuss the practical steps involved in installing the electrical system for an above-ground pool pump motor using PVC conduit, insulated ground wire, and expansion joints. Firstly, plan the layout of the conduit run. Determine the location of the pump motor, the electrical panel, and any other electrical equipment. Measure the distance between these points and plan the route of the conduit run. Secondly, select the appropriate size and type of PVC conduit. The size of the conduit will depend on the number and size of the conductors being installed. The type of conduit will depend on the specific application and environmental conditions. Thirdly, install the PVC conduit. This involves cutting the conduit to the desired length, assembling the sections with PVC cement, and securing the conduit to the wall or other supports. Make sure to use appropriate fittings and connectors to ensure a watertight and secure connection. Fourthly, install the insulated ground wire. The ground wire should be run inside the conduit along with the other conductors. Connect the ground wire to the grounding terminals at the pump motor, the electrical panel, and any other grounded metal parts. Fifthly, install expansion joints as needed. Expansion joints should be installed at regular intervals to accommodate the thermal expansion and contraction of the conduit. Follow the manufacturer's instructions for installing the expansion joints. Sixthly, pull the conductors through the conduit. Use a fish tape or other pulling device to pull the conductors through the conduit. Be careful not to damage the insulation on the conductors. Seventhly, connect the conductors to the pump motor and the electrical panel. Follow the manufacturer's instructions for making the connections. Make sure to use appropriate connectors and terminals to ensure a secure and reliable connection. Eighthly, install a GFCI. A GFCI should be installed in the circuit that supplies power to the pump motor. The GFCI can be installed at the electrical panel or at a location near the pump motor. Ninthly, test the installation. Use a multimeter to test the continuity of the ground wire and the insulation resistance of the conductors. Verify that the GFCI is functioning properly. Tenthly, inspect the installation. Have the installation inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. In summary, running 12/2 UF cable to feed an above-ground pool pump motor is not a recommended practice due to code requirements and safety concerns. The proper installation involves using PVC conduit with an insulated ground wire and expansion joints, following the guidelines outlined in Article 680 of the NEC. By adhering to these guidelines, you can ensure a safe and compliant electrical system for your above-ground pool. The NEC is updated regularly, typically every 3 years, so it's crucial to consult the latest edition and any local amendments to ensure compliance with the most current regulations. Additionally, local codes and regulations may have specific requirements that differ from the NEC, so it's always best to check with your local building department or electrical inspector before starting any electrical work. Finally, remember that electrical work can be dangerous, and it's always best to hire a qualified electrician to perform the installation if you are not comfortable working with electricity. A qualified electrician has the knowledge, skills, and experience to ensure that the installation is done safely and correctly.